Welcome to the next session of Finite Element Analysis. In this session, I am solving a question of beam element which is under the effect of UVL. For the beam shown below, determine the support reactions at A and B, which means I have to calculate the reaction forces at A and B. The length of the beam is given as 6 meter and the maximum load is given as 20 kilonewton per meter. I'll first start with discretization, which is my first step. I'll draw the same beam here. So this is the beam. At end A there is a fixed end and here there is a reaction, as you can see. So I'll mark this node as 1, this node as 2. This entire thing is element 1. Each node will have 2 degrees of freedom. So I'm marking 1, 2 and 3, 4. So this completes my discretization diagram. Next I'll go to step 2, which is development of EME. Now I'll write down the equation for the EME of a decreasing type of UVL. So this is the equation. I'll calculate 2EI upon HE cube. Now if you read the question, the value of E and I is not given. So I'll leave it in terms of E and I itself. So this will be 2 into EI. Value of H is 6 cube. So this becomes 2EI upon 6 cube kilonewton per meter. I'll leave it to whatever it is. Next I'll calculate FHE upon 60. The value of F will be minus 20. HE is 6 and this is 60. So this makes it 10 and the answer is minus 2 kilonewton. Now I'll substitute these two values in this equation. Also I'll substitute the value of HE over here, which is 6 meter. So this is what I obtained by substituting these two values and also the value of HE. Now next what I'll do is I'm going to multiply this numbers inside. I'll leave EI outside. When I multiply in 2 and divide by 6 cube, which is 216, they all will go into decimal values, but it's okay because anyways I'm not going to write the GME as I have only one element. So let's write it down. So this is the equation that I have obtained. Now element 1 is between node 1 and 2 and the degree of freedom is 1, 2, 3, 4. So I'll write here 1, 2, 3, 4, 1, 2, 3, 4. Now the equation that I have written over here itself is going to be my GME because there is only one element. So I'll go for the third step, which is imposing of boundary conditions. These are the unknown values which I need to find. Now when I look here, at end A it is fixed. So my deflection and slope both will be 0, which is W1 and W2. At point B, the deflection will be 0 and bending moment will be 0 because I have a reaction here, which means this could have been a hinge or a roller. So I will write down the boundary conditions now. This is 0, 0. I'll write here node 1 is fixed. These two have to be question mark. W3 will be 0. I'll write here node 2 has a reaction. So it could be a hinge or a roller. And this will be question mark. This will be 0. So these are the unknown values Q1, Q2, Q3 and W4. Now if you look at this equation, W1 is 0, W2 is 0, W3 is 0, which means I'll be neglecting first row, second row, third row, first column, second column, third column. So what remains is only this fourth term over here and I'll multiply and get the value of W4. So I'll have EI into 0.667 is equal to, W4 is equal to minus 24 plus Q4. So when I solve this, Q4 is 0, therefore I have W4 as minus 36 upon EI. Since this is slope, it will be in radians. This is slope at node 2. Next I'll write equations for Q1, Q2, Q3 and I'll calculate the values. Therefore I have Therefore, I obtained Q1 as 48 kilonewton. Now, this is the shear force or the reaction at node 1, or you can call it as node A. Next, I'll write down for Q2. Therefore, I obtain Q2 as minus 48 kilonewton meter. This is the bending moment at node 1. This is also a reaction which I am supposed to calculate at node A. You can write down. Next, I'll write down for Q3. Therefore, I obtain Q3 as 12 kilonewton. This is shear force or reaction at node 2, which is B. So these are also the answers which I have just written. Next, I'll go for the check step. For that, I'm going to draw the FBD. At node A, there will be a reaction Q1 as I just wrote, whose value is 48 kilonewton. Also, there is a moment over here. Let me mark it as clockwise. Q2 is minus 48 kilonewton meter. At point B, there is a reaction Q3, which is 12 kilonewton. And also there is a UVL on this body. So I have to calculate its value and place it at 1/3 from this end. So I'll write here, this is half 6 into 20, which makes it to 60 kilonewton. This will be at 2 meter from end A and 4 meter from end B. Now I'll write down summation of force in y direction should be 0. Upward direction forces I'm considering as positive. So I have 48 going upward minus 60 plus 12. This is straight away 0. Next, summation of moment, say about point A is 0. Clockwise I'll consider as positive. First I have the moment at A itself, which is minus 48. Next, 60 turns clockwise, so plus 60 into 2, and this 12 will turn anti-clockwise, so minus 12 into 6. This becomes minus 48 plus 120 minus 72, which is minus 120 plus 120, making it to 0. Hence, I have tallied my solution. So with this, I end the session. I hope you have understood the numerical. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.